In this video, I'm going to present you my understanding about assignment 3. Firstly, we are going to create and evaluate nonlinear models for classifying data into two classes. Those are positive and negative classes. For that, we are going to import certain libraries. They are sklearn, matplot library. And from sklearn, we are going to import make regression, make circles. And from MATLAB, we are going to import PLT for plotting graphs. And we are also going to import train test split for training and testing the data. Uh, Firstly, after importing these certain packages, we are going to generate circular data in which we are going to take 1,000 examples and we are going to make circles. After that, we are going to save the generated data of 1,000 circles in data X and data Y. We are going to use np numpy.where for separating the indices into positive and negative examples. That means if y is equal to 1, it comes under positive. If y is equal to 0, and it comes under negative. Here is the way in which we are going to separate positive and negative data that's generated from make circles. After that, we are going to code uh, in which we are going to plot the graph. Firstly, we are going to take the size of the graph as 10:7 ratio, and dot per inches are going to be 80. And if positive index, we are going to color it as red, and we are going to label positive indexes as positive examples. Or in the same way, we are going to plot negative indexes which are 0, and we are going to color it as blue, and we are going to label it as negative examples. After that, we are going to label x label as x1 and y label as x2. Here, after that, we are going to plot the graph. This is how we are going to plot the graph. Uh, Here we took factor is equal to 0.1, which is uh, noise. Factor is a ratio between bigger and smaller circle in the whole 1,000 circles which are generated. And the noise here is also 0.1, which is very low because noise should not be too high. If noise is too high, we can produce perfect data, so that noise should be very low. Here is how we are going to differentiate positive and negative points. After that, we are going to plot the graph using this particular code. And this is how the graph is being plotted. Here, the positive circles are colored as red and negative circles are colored as blue. Uh, Here, the data is in disturbed format, which is not in continuous. And blue dots are negative examples, which is the outer circle, and the positive examples are in the disturbed format. After that, we are going to split the whole data into 80% for training and 20% for testing. And we are going to take the variables xtrain, xtest, ytrain, and ytest for testing and training the whole data sets. We are using SVC to create three classifiers. They are linear, polynomial, and RBF. We are going to name it as model linear, model poly, and model RBF. After that, we are going to train the classifiers on test set using fit method. This is the way we are going to import test train split, which is used to train and test data sets, and we are going to assign test size as 0.20. That means we are going, as shown above, we are going to use 20% of data for testing, so that we are going to assign test size as 0.2, and random state is equal to 42. That means if two individuals are running the same code, they'll get an exact same output, so that we are going to assign random state as 42. Here we are going to do model linear. which is SVC of kernel is equal to linear, and we are going to perform fit operation on X train and Y train. After that, we are going to take poly. We are going to assign kernel as poly, and degree is equal to 10. A degree is equal to 10 means there are going to be 10 polynomials starting from x to x power 9. And one variable is going to be present in that 10 degrees. And we are going to perform fit operation. And we are going to perform fit operation. After that, we are going to take RBF, and we are going to set kernel as RBF, and we are going to perform fit operation on X train and Y train. After that, we are going to print the score that obtained by a model for RBF, X test, Y test, and X test, Y test of linear, and X test, Y test of polynomial. Here, as we can see, the output generated by model linear is too low because, as we said in the stat, we are going to provide a solution for non-linear models. Um, the accuracy for the non-linear models is going to be very low. So that this is the proof that nonlinear models accuracy is going to be very low, and polynomial and IBF score is same, that is 1. Thank you.